Start timer. Let's go. So, hello everyone. My name is Sebastian Rivera. I'm a software engineer at Azure SQL DB in Microsoft. And today I'm going to talk about green software engineering principles. Let's see what that is. So, the first of all, my motivation to be here talking about this topic is I realized that from a software engineering perspective, there's still some ways in which we can contribute to global climate change and sustainability. We're constantly using resources and emitting some pollution by the electricity consumed by our computers, servers, and everything. And still today, the majority of the electricity that we use on our daily day to like on a daily basis, it's produced by fossil fuels, and that's still hurting our planet. So I found this topic really interesting, and I would like to share with you what green software engineering is and which are the principles that motivate this discipline. So this new discipline is an intersection between other disciplines that we may already know, like climate science, software and hardware engineering, maybe some part of like electrical and engineering, and also data center design. And all of these revolves around the idea of creating consciousness on the carbon that we emit as users or like as providers of like software applications. And it impacts even more right now on the cloud, because we're growing and growing more data centers, not only in Microsoft but in many other like cloud providers. So we need to think in and change the way in which we actually deploy our cloud data centers, and also change or help our customers and developers change their mindset in the way they develop their applications. So today I'm going to share with you, there's 8 principles. For the sake of time, it's kind of hard to go through all of them. I'm going to go through the most important ones that I find that will be useful to you. And at the end, I'm just going to give you some resources that you can follow up and learn more about the remaining ones that we're not gonna discuss today. So the first one is carbon, right? And it's kind of what we already mentioned. The idea is that we want to create more carbon efficient applications, and this warming blanket that's right now revolving our planet Earth, we want to diminish it in the like as much as possible. So the idea is that for every gram of carbon that we emit to the atmosphere, we want to get out the most value, right? And not only be throwing out using out electricity with no sense, and also like having some emissions that are not really useful. So the we as software engineers, or like people that's related to data, we may think that we are not doing like my that was my first thought, like how can I be contributing too much to carbon emissions? Well, electricity is the second principle. This is like a natural flow, and we're every day using electricity on our jobs, and even more now that we're in the like working from home. It's something that's essential. Like I can't imagine a world without electricity today, and electricity is also like powering the internet. So everything right now depends on this. So we can be fooled that thinking that electricity is not damaging the earth, but yeah, as I mentioned before, still today most of the production of electricity is non clean. So that's the second principle that I want to uh, reinforce today, that we need to build apps that are energy efficient. Um, and the third principle is carbon intensity. Uh, this one is more about the idea that not all electricity has the same environmental impact. And that means that, yeah, as most of the electricity is created by burning fossil fuels, but we are gaining some space on the green sources for energy. So we we need to also think about this when creating an app and maybe running some heavy workloads. And here's a graph that represents these in a very like a clear way. So if we see the graph on the left, this pile of electricity was created in its majority by wind and solar sources. So the carbon intensity that this consumption has is only 120 grams of carbon dioxide per kilowatt hour, which is these grams of carbon dioxide per kilowatt hour is the way in which people measures the carbon intensity. So if you see, and we go to the other column, it is in its majority produced by coal and gas, and it doubles or goes even beyond the double of the carbon intensity to 350. So maybe just by shifting a heavy workload from a place where there's no too much green energy production to another place where it is, just from data center to data center, you can be saving up to half of the emissions that you would have created on the other data center. Um, then I'm gonna jump to the fifth one, which is energy proportionality. And energy proportionality, it revolves around the idea of the utilization of our devices. And the rule of thumb here is that on a higher utilization, there's a more efficient use of energy. And here I'm also gonna leverage from a nice graph, which is showing the power versus the utilization. And there's this 0% consumption of static energy, which is 100 watts. And if we move to its maximum utilization, using CPU and all the resources to 100%, there's only 100 watts of difference. So it's kind of amazing to think that there's only like you could be, if you have all the servers idle, it will be still consuming half of the energy on the same scenario as having them running on 100% utilization. So this is more in the way of thinking that if you can run a workload on less amount of servers, that would be more energy efficient, and the energy proportionality will be much better. So yeah, we those are the principles that I want to share with you today. Now there's some architectures that people has proposed, and right now they're becoming more common on the day to day. So one of them is serverless, and serverless can help us create more carbon efficient applications, in the sense that the utilization of the servers from a cloud provider perspective could be better, and you could, instead of allocating a full server to one customer or one company, you could have multiple customers using the same server throughout a whole day or a week or a month. And this is just one example of some architectures that could help start, like people can use them to start applying some of these principles. Microsoft already has some interesting, some of their products are already having these serverless versions, like SQL DB, Azure Functions, Event Grid, Cosmos DB, and Logic Apps. All of them have serverless offering. So that could be the first step to actually start implementing these principles on a day-to-day life. And with that, we got to the end of my presentation. I just want to share these two useful resources: Principles.green, which is an open source community that people's like just contributing to promote the creation of these principles and the usage of these principles. And this Green Software Foundation is a new foundation that was announced a couple of days ago during the Build conference of Microsoft, and it's powered by GitHub, Microsoft, Accenture, and ThoughtWorks. And these two are just like some resources that you can have to follow up and learn more about this topic. So with that, I'm gonna finish. Thank you everyone for your time, and I'm happy to follow up on email or Twitter. Yeah, this is a 96 Sebastian Rivera 96.